The universe came into existence through the Big Bang event approximately 13.8 billion years ago. In its initial stages, the universe predominantly consisted of simple elements, primarily hydrogen and helium, simplest elements with a nucleus of 1 or 2 protons. Nevertheless, these basic atoms underwent a remarkable transformation, evolving into the complex life forms we find on Earth today. In this video, we aim to provide a brief exploration of the process behind this remarkable transformation. Life, as we know it, has undeniably emerged through the process of evolution, spanning billions of years, starting from unicellular organisms. Yet, the success of this evolutionary journey was made possible due to the presence of the crucial elements found on Earth. These fundamental elements essential for life include carbon, iron, oxygen, nitrogen, calcium, and more. Creating more complex elements with an increased number of protons in the nuclei is a formidable challenge due to the repulsive force between protons, requiring a substantial amount of energy. Consequently, the fundamental elements necessary for life can be synthesized from simple hydrogen atoms, a process known as stellar nucleosynthesis, albeit one demanding a significant amount of energy. Now, let's explore how these elements were created from atoms and how they eventually found their way to Earth. The key actors on this transformation are the stars, especially the massive ones, and the answers to these questions are included in the life cycle of stars. The birth of a star commences within a nebula, an immense expanse of gas and clouds, primarily composed of hydrogen atoms. Due to the substantial mass of nebulas, gravitational forces between the gas particles become significant. Gravitational attraction brings these gas elements together, initiating the contraction of the nebula. As the contraction progresses, hydrogen atoms collide more frequently, leading to the generation of heat. This contraction and heat generation continue until a critical point is reached. Instead of rebounding, the 2 hydrogen atoms undergo nuclear fusion, resulting in the creation of helium. This fusion process releases an immense amount of energy and heat, which in turn strives to expand the star. In this case, the heat generated by the nuclear fusions expands the gas, whereas the gravitational force acts to squeeze it. Once these 2 opposite forces are in balance, the star is born, and for billions of years, the star generates light, warmth, and energy to the universe until the star consumes most of its hydrogen atoms and runs out of fuel. As nuclear fusions are reduced, the star is cooled off and the gravitational force gains the upper hand. As the star contracts, under the immense pressure and heat, heavier elements begin to form on the core of the star. In the event of a massive star, the contraction continues until the point where the star can no longer withstand the pressure and ultimately explodes. This explosion is known as a supernova, representing the most colossal explosion in the universe. The supernova explosion releases and spreads all the heavy elements created on its core to the universe. Billions of years later, in areas where there is a concentration of gas and the previously dispersed heavy elements, planets take shape under the influence of gravitational forces. These planets harbor the entire array of heavy elements originally forged within the star's core. Our home, Earth, is one of such planets, which is created by the remnants of the elements at earlier supernovae and massive stars created at the early stages of the universe. Thanks to its ideal distance from the Sun, the suitable temperature, and the presence of essential elements, life has flourished here.